In this video we're going to learn all about empirical formulae and calculations that involve these. Okay, so first of all, what is the empirical formula of a compound? We know about the molecular formula. That tells us how many of each type of atom are present in a molecule of the compound. So for example, that's the formula, that's a molecular formula for glucose. That tells us that in one molecule of glucose there are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Okay, now the empirical formula, that's where if there's a common factor to all of those numbers, you can simplify down to the nearest whole number, the nearest whole number ratio. Okay, so in this case, a common factor is 6. So 6 divided by 6 is 1, so we end up with 1 lot of carbon. 12 divided by 6 is 2, so 2 lots of hydrogen. And 6 divided by 6 is 1, so the empirical formula for glucose is CH2O. Okay, so I've divided all of those numbers by 6 to end up with the empirical formula. Now, let's have a look at a couple of other examples. Let's say we have this formula over here. Can we simplify this down? Is there anything that we can divide all of these numbers by? The answer is no. Okay, so this is actually the empirical formula for this compound because there isn't a common factor that we can divide all of these numbers by. So that's the empirical formula. Okay, what about this one over here? Okay, well in this case here, both of these numbers can be divided by 2, so we can do that. Okay, so C2 becomes just C, and H6 becomes H3. So that's the molecular formula, and this is the empirical formula. Okay, and the last example is this one. And in this case, we can divide all of these numbers by 2 again. So if I divide 4 by 2, that becomes 2. 8 divided by 2 becomes 4. And 2 divided by 2 becomes 1. So that's the molecular formula, and this is the empirical formula. Okay, so basically we're simplifying down. Okay, we're going to work through examples of empirical formula problems. All of these are in your OneNote. I've tried to pick out different types of problems so that once I've worked through these examples, hopefully you'll be able to keep going with the rest of the page. Okay, in example 1, we've got a sample of magnesium and it's burnt to produce magnesium oxide, and we've got to work out the empirical formula for the magnesium oxide. Okay, the first thing that we're going to do is that we're going to work out the mass of oxygen that reacted with magnesium. So since we had 2.41 grams of magnesium and the mass of the magnesium oxide has increased to 4.02, the mass of oxygen must be 4.02 minus 2.41. And that works out to be 1.61 grams. Okay, next step is to work out the ratio of the number of moles in this compound. So we're going to do the ratio of the number of moles of magnesium compared to the number of moles of oxygen. So that's going to be the mass of magnesium divided by the molar mass, which I'm going to get from the periodic table, and that's 24.31. And then on the other side, the mass of oxygen, which is 1.61, divided by the molar mass of oxygen, which I can work out from the periodic table to be 16. Okay, now when I put this into a calculator, that works out to be 0.1 is to 0.1, which is the same as 1 to 1. So therefore, the empirical formula is MgO. Okay, so in the empirical formula, there's the ratio of Mg to oxygen is 1 to 1. Moving on to example 2. This time we've been given the percentage composition of the various elements that make up the compound. Okay, so whether we've got percentage composition or the actual mass, the procedure is exactly the same. The first thing that we're going to do is to work out the ratio of the number of moles of the different elements. And the way I'm going to do that is to divide each of these percentages by the molar mass for each of the elements. Okay, again, putting this into a calculator, so if I put 69.2 divided by 107.9 into a calculator, that works out to be 0.64. This works out to be 0.32. And this works out to be 1.28. Okay, now to work out the whole number ratio, usually the easiest way to do that is to divide everything by the smallest number, which in this case is 0.32. And again, putting this into a calculator, we end up with 2 is to 1 is to 4. So the ratio of silver to sulfur to oxygen is 2 to 1 to 4. So the empirical formula is Ag2SO4. Okay, now example 3 is a little bit trickier. It's more a case of trying to work out what the question is asking you. So they've told you that you've got samples of different metals, and they've told you by what percentage the mass of each of those metals increases. And then they've asked you to calculate the mass of oxygen that is combined with 5 grams of each metal. Now I'm going to work through aluminium as an example, and then hopefully by following the same steps you can do the other metals. Okay, so what they've basically told us in this question is that we've got to assume that we've got 5 grams of the metal. So in other words, we've got 5 grams of aluminium. Okay, first thing we've got to do is to work out the mass of oxygen that's combined with the 5 grams of the metal. So in the case of aluminium, the mass increases by 89%. So the mass of oxygen that combines with the aluminium will be 89%, which is 89 over 100 times 5. And that works out to be 4.45 grams. Okay, so that's part A. And then for part B, we've got to work out the empirical formula for the metal oxide. So that's exactly the same steps as before. Now that we've got the mass of the two elements, we work out in what ratio the moles are. So putting that into a calculator, that works out to be 0.19 is to 0.28. Again, we can divide by the smallest number. And we can see we don't actually end up with a whole number ratio here. We end up with 1 is to 1.5, but to make that into a whole number ratio, I'm going to multiply by 2, so that's 2 is to 3. Okay, so the ratio of aluminium to oxygen is 2 to 3. What that means is that the empirical formula is Al2O3. Okay, now the last example I'm going to work through is question 29. In this case, we've been told that we've got 1 gram samples of each metal, and we've got to work out the increase in mass when each of the metals combines with oxygen. Okay, so again, I'll work through the first example, so lithium with you, and then hopefully you can follow the same steps to do the other 3 metals. Okay, so when lithium reacts with oxygen, because lithium's got a valency of 1 and oxygen's got a valency of 2, the compound that's formed is Li2O. Okay, now by the way, that equation is not balanced. Okay, if I balance it, it looks like this. Okay, but the important thing is that the compound has got the formula Li2O. Okay, so we're kind of working backwards in this question here. We know what the formula is, and we've got to work out the increase in mass when the metal reacts with oxygen. Okay, so first step is to work out the number of moles of lithium if we've got 1 gram of lithium. So it's all in the question, we've got 1 gram of the metal. So the number of moles of lithium is going to be 1 divided by the molar mass of lithium, which is 6.941. That works out to be 0.144. Okay. Now, looking at the formula for lithium oxide, the ratio of lithium to oxygen is 2 to 1. So what that means is that the number of moles of oxygen will be half this. Okay, so the number of moles of oxygen will be 0.144 divided by 2, which works out to be 0.072. And then the last step is to work out the mass of oxygen that gets added to magnesium, and that's by working out, by multiplying the number of moles by the molar mass. So the number of moles is 0.072, and the molar mass of oxygen is 16. So that works out to be 1.15 grams. Okay. Now, the second part of the question, they've asked you to identify 2 factors that determine the percentage increase. Well, one important factor is the valency of the metal. So in the case of lithium, it's got a valency of 1. So that means that it's going to react. That means that for each lithium atom, only half an atom of oxygen is going to be added on, because they're in a ratio 2 to 1. Okay? Whereas magnesium, the ratio is going to be 1 to 1. So the valency of the metal is important. Okay, and the other factor that's important is the molar mass of the metal. So if you've got a metal that's very light and that reacts with oxygen, the increase in mass will be much bigger percentage increase. Whereas if the atoms of the metal are very heavy, then when it reacts with oxygen, the percentage increase will be much smaller. Okay, so the 2 factors that play a part are the valency of the metal and the molar mass of the metal. Okay, so in this video I've worked through lots of examples of this type of problem. Now I'd like you to have a go at solving some problems on your own. What I would recommend that you do is that you make a start, and when you get stuck, try and find an example in the video that is similar to what you're trying to do, and re-watch that little bit of the video if you need to. Okay?